Hello and welcome to this video where we'll go into Gemini API and I'll show you how to get started with the Gemini API in Python. We will go into getting the API key first and then using the API key to put in a .env file and then connect to Gemini. And for Gemini, I will show you text generation. I will talk a little bit about the tokens and how to check the different tokens cost for different types of outputs and how to count that. And then we will go more into different things such as system instructions, thinking, temperature, and multimodal inputs. For multimodal inputs, I will put in an image of myself, and then I will just make the LLM answer question based on that image. That will be quite interesting to see how you can leverage the Gemini API, and the Gemini API has a really nice free tier that we will work with. That's why in many of my tutorials I choose Gemini API because it's very easy to get started with and also has a really nice free tier. Also, it's really nice models. Let's dive into the browser first to find out where to get the API key. Here I am in the browser and just search in Google Gemini API and we'll get into this page here, Google AI for Developers. This has really nice documentation about the Gemini API, especially like, for example, how to get started. Here you click on this one to get the Gemini API key. Let's see, yeah. And here you can see I'm inside of Google AI Studio. Make sure that you have a Google account and go into this with your Google account. And then here you can do create API key. As you can see, I'm also using a free tier here. And you can find your key over here. Click on it and copy it after you have created your API key. Then after that, I will go into Visual Studio Code. Here I am in Visual Studio Code, and as you can see, it's empty. Let's start with creating a few things. I want to create .env, and here I will also do a few setups. I will do v init, and then I will just remove this main.py because I don't want that. And then I will do uv add. What do I want to add? I want to add Google. Let me see. First of all, I need IPy kernel. I will need to have Google-generative AI. Yes. Starting with this. Yes. And maybe we need other things, but as you can see, we should also have a git ignore. And for the git ignore, you should have .env in it if you're working in a Git and GitHub repository. Here in .env, we want to put in Google _ API _ key equals to, here is your API key. API key that you found before in Google AI Studio. I won't put in my real key here. I will pause the video and do that later on. Now we can start with a Jupyter notebook. I will do touch Gemini intro.ipnb. Here I will start with Gemini intro. To work with Gemini, let's see, Python environments, we choose this Gemini intro. I will close down my terminal. I think I don't need that anymore. I will put this down here. Let's see, I will change this to Python first. From Google, import Gen AI. Oh, actually, I installed the old one. I need to uv add Google-Gen AI. Gen AI, not generative AI. And this one should work. Yes, now it works. We start with client equals to genai.client. This one, it will automatically get the API key from the environment variable if it's named Gemini API key or Google API key. I'll run this one. And now we will do response equals to client.models.generate content. And here model, I will start with Gemini-2.5-Flash. And the contents equals to, I will just give it some content. Generate some funny jokes about data engineering. Give 5 points in markdown formats, for example. Print response.text. And I get an error. And what is my error? Well, API key not valid. Yes, because I will put in my real API key now. I'll pause the video and do that. You can see that it works. And it works because I have in my .env, I have put in Google_API_key. Basically, I put in like Google_API_key equals to my actual API key. And because of that, if it's named Google_API_key or Gemini_API_key, then this client.genai.client, this will automatically find it. You don't need to use load.env as you normally do, because this is a special case. Good to know. Then I ran this one and you can see, yes, it works. Here are 5 funny jokes about data engineering. Why did the data pipeline break up with the data scientist? Because it couldn't handle their constant schema changes and commitment issues. Wow, this is fun. Yes, let's move on. We don't need to read all the jokes, even if you really want to. Let's dive into the response object. So you can see this is the response. What is this? You can see generate content response, and then there is a lot of parts, etc. And then you can see if you do .text, you get all the text. Response.text, we get all the text. However, let's dive into this a little bit. This is an object in Python, and in objects in Python, they have a dunder-dict. If you know a little bit more in object-oriented programming, you'll understand this one. They have something called dunder-dict. And inside of dunder-dict, you can see it's the dictionary. Each objects in Python are actually, they have the dictionary, okay? We have dunder-dict, and you can see this is the dictionary object. And as it's a dictionary, you can do .keys to find out which keys are there. We can see there's something called SDK HTTP response, candidates, create time, model version. I want you to check this out. What you can do is that you can check out each of these to find if there's something special. And to check it out, what you need to do is to do response dot, for example, I'll check out the usage metadata. And you can see this is a generate content response usage metadata. Basically, this is an instance of this class. And you have different types of things, for example, candidates token count, prompt token count, etc. While talking about tokens, let's get into more about tokens, because this is an important topic. Analyze tokens. Basically, tokens are basic units of text for LLMs used to process and generate language. It is how LLMs divide the text into smaller units. And for simplicity, you can see it as words, but actually that's not the complete truth, because, for example, a word could be divided into several smaller tokens. And also tokens, they are what you pay for when you use an LLM API. Gemini API, you pay for the tokens. But we are in the free tier, and then the free tier, it allows for different things. You can look it up in the documentation, but I will copy this one, which I found in the documentation. For the free tier in Gemini API, it allows for example, Gemini 2.5 Flash, it has requests per minute, 10. You can do 10 requests per minute. You have tokens per minute is 250K, and requests per day, you have 250 requests per day. And also there's a chance of a server overload because you're sharing the same resources with everyone else using the free tier. It could be down whenever. But it is a very nice way to develop your app, and then when you're finished with your app, you want to put it into production, you go into a paid tier. This is the metadata. We will go into more about this one. First, we can take a look into this instance of this response dot. I will call this metadata actually. Metadata equals to this one and metadata. And let's take a look into if this instance looks like a Pydantic model. Let's take a look if that is the case. From Pydantic, import base model. And as you have seen here, I haven't installed Pydantic per se, but you can see it exists because apparently it's a dependency for Gemini. The generative Gen AI. Let's run this one, and you can see it's true. It is an instance of a base model, as you've seen. And as it is an instance of a base model, we can use the dot notation to get the different things we're interested in. Let's take a look what we could be interested in. Metadata dot candidates token count 192. Let's print a little bit of things. Print. I want to make an F string here. Metadata count, candidates token count. This is basically the output tokens, prints output tokens, which is number of tokens in model's response. This is the output token. And then we had a few more. I'll do another print here. Tokens in user input or user prompt. You prompted something. We prompted, if we look up a little bit, we prompted to get this joke, generate some funny jokes about data engineering, give 5 points in markdown format. That is our prompt. And the prompt is a number of words, which is divided into number of tokens. We'll see how many tokens they counted that for. Print f-string metadata dot prompt token count equals, and you can see 16. We had 16, and there's something else that we can take a look into metadata directly here. You can see 192 candidates token count, 16 is the prompt token count. And then we have the modality. As I said, Gemini model is multimodal. It means that we can have different modalities. For example, we can handle audio, we can handle text, we can handle images, video. What we have here is text modality, text. And then there's something else. Thoughts token count 1223. This was very expensive. Thoughts token count. Let me just copy this and place this one here. Disappear metadata.thoughts token count equals, and you can see 1223. Yes. Tokens used for internal thinking. The model is a thinking model, which means it's a reasoning step by step. And if it's reasoning step by step, then this reasoning costs token, because this is part of how many tokens are used, because it's need to reason to generate the answer. If you just took a look into the prompt, very few tokens, and the answer, very few tokens. But the thinking, a lot of tokens, but they are not written out. Let's continue with one more here. Copy this one. Now I want to see the total tokens used. And then for that we have total token count, and you can see 1431. If you add them together, it should add up to 1431. I won't do that now. But now you know that if you think like you're building a system where you use this type of thinking reasoning model, and actually you might be thinking, yeah, it doesn't help much with the thinking. Maybe for this simple application, I don't need that much thinking. In that case, then we're wasting money on the thinking while we could decrease the thinking. And like how much thinking you should use, that is a hyperparameter for you to tune. If you have learned, for example, deep learning, then you know that, or machine learning, then you know that there's a lot of hyperparameters to tune. And here is a similar thing. You have the thinking parameter, like how much thinking should I have? And then you need to evaluate yourself on how your responses are based on your particular application. That it's possible to save money by changing the amount of thinking used. And talking about thinking, let's move directly into that. The thinking process takes a lot of time. It takes a lot of tokens. As you saw, it was like 10 times or even more than 10 times the other tokens used. To do that, we do response equals the client dot model dot generate content, the same as before. And we have model, actually I could have copied this one, Gemini 2.5 flash and contents. Actually, I will go and copy it. Sorry, I should have done that before. Basically, I use the same here. And now I want to have a config. Config equals to, and here I need to import also from Google, but Gen AI import types. This is also stated in the documentation. I've taken it from documentation directly. We have types dot generate content config. This is the config for generate content. The config I want to put in is thinking config, and this is types dot thinking config, and you pick the thinking budget, and here I could place it to 0, for example. And we can do print response dot text. Server error. This happens sometimes, as I said before, because we're sharing the resources because of the free tier. I'll run it again. Yeah, it's server error again. I will pause the video and wait for a while. Now I ran it again after I waited for a little bit, and you saw that it's the same code, but we had like thinking budget of 0. And here you can see the jokes have become a little bit different. Let's take a look here. Why did the data engineer break up with the API? Because it had too many unhandled exceptions in the relationships. Is that good? I'm not sure. A data engineer walks into a bar. The bartender asks, "What will it be?" The data engineer replies, "I'll take a clean, normalized, and well-structured gin and tonic, please, and make sure it's idempotent." Yeah, I guess this is quite funny if you're into data engineering jokes, but the point is that it works even if we had lower thinking budget, and you saw also here 2.1 seconds compared to the other one, which took more time. It's also like a little bit faster because we don't have the thinking involved. Then the question is, you need to decide like, is this good enough jokes for you that you will skip the thinking, or is the thinking having much more quality jokes? And do you need to have this speed, and are you willing to pay the tokens? There are these type of trade-offs. So usually with all types of technology, there's a lot of trade-offs. Let's take a look into our response dot usage metadata. This is our new metadata now. And you can see it's much cheaper. We have total token count of 267. We don't even have a thinking anymore. You see much more cheaper. Let's continue here. We will go into something called system instructions. System instructions. The system instructions are basically like you give something to the model that it has this as its normal state, basically. It's like the default instruction to give it. For example, of a system instruction, we can do something like this. And let me just copy this code because I will reuse it again here. And I will do system instruction equals to, let me do a multi-line string here. You are a joking robot called a robot, which will always answer with a programming joke. I hope that this will be fun. Then we can do a prompt here. Prompt equals what is the weather today, for example. Then we can change this one. Content, the contents is basically this prompt. And as you see, we lift them out into variables. It means that it's very simple to make it into a function or a class where you can reuse this. Here, prompt, I can have the config, types generate content config. Yes, it's the same. I will remove the thinking as well. And we'll have a system instruction. As a system instruction like this. Let's test this out. Response.text. Let's print it and see. Let's see if this is funny. You can see here server error, and yeah, it's overloaded again. This happens quite a lot today, actually. Google AI Studio for this model 2.5 Flash, it's overloaded quite often. If I run it again, see if it's again. Then you can just change to another model, for example, 2.0 Flash, and it works like a charm. It's a lower model, but yeah, it works at least. Let's see if this works. Why did the private classes break up? Because they never saw each other. Sorry, I'm not a kid to give you the weather, but I can always make you laugh with a coding joke. Let me run again and see if there's something else. There's a CPP, C+ program, cout. The weather today is always sunny, just like your code when it compiles on the first try. Just kidding. Good luck debugging. End line. Nice. It works. We used another model and it worked. Great. Let's take a look into response.usage metadata. And now you can see that this is quite interesting. You have 73 for the candidate's token count. And you have prompt token count 29. 29 is actually including both the system instruction and the prompt. If you just take a look into, let me show you here. If you take a look into the prompt, you have this many characters. We can split it, and you can say length of this splitting is 5. It shouldn't give like 29 token count because of that. This is the length of the prompt, and then we have length of system instruction dot split, and you can see 16. 16 plus 5 is 21, and then there's some other. There are some formatting overhead that it becomes like 29 tokens in total. And also each word is not corresponding to one token. It could be divided into. We say that 21 and then plus a few more for the system instruction and the prompt. And then we have some overhead as well, formatting overhead. Let's now experiment with something else. Temperature. The temperature is basically giving how creative your model is. Basically, as you've seen from the theory, LLM is basically a next word predictor. It's predicting what the next word should be, or the next token should be. And then it's based on all its training data, which is from the internet. And based on that, it will find the most probable word that comes after what's previously been written. And if you have temperature equals 0, then it's deterministic. It will always give the most probable one. However, when you change the temperature, it will be more creative. Maybe it won't take the most probable word. It will take maybe the third, fourth, fifth probable word and put it together, that it will become more and more creative. That is basically, it works like that. Let's try a story, for example. Story prompt equals to, let me change this to Markdown first. Change it to Python. I will go back here and copy what we have here. Copy this one. Prompt is story prompt thinking config. Yeah, actually we can have some thinking to make it a little bit nicer. System instruction. No, I don't have a system instruction now. But I do want to have types dot generate content config. Let's see. Config. Oh, I already had it there. Types dot generate content config and temperature equals to 0. This is the lowest temperature. Let's see if 2.5 works now. If it doesn't work, we change. We call this response. I will call it boring story. Boring story print boring story dot text. And let's see if it works. A small gray rabbit, its fur the color of a stormy sky, twitched its nose, sniffing the damp morning air for tender shoots. With a sudden flick of its ear, it vanished into the dense undergrowth, a silent gray blur against the green. I don't understand this story at all, but let's twist it a little bit. Let's change the temperature to 2.0, which is the highest. Or actually, before we do that, let us run again with 0 to see if it's becoming same story or not. It's not the same story because it starts differently. Small gray rabbit, its fur the color of twilight, twitched its nose. To see twitch its nose came again. Sampling the scent of fresh. It's a little bit different, but still quite boring. Let's copy this one and run. Oh, sorry, I ran it again. Yeah, you can see it's deterministic or slightly non-deterministic. But you can see I ran it twice and the second time we got exactly same as first time. Now I will change the temperature to 2. This is the highest one. I will call this a creative story. Creative story.text. Run it. Unavailable. Unfortunate. Yeah, let's change to 2.0. Yeah, Barnaby, the gray rabbit, nervously twitched his nose as a shadow passed overhead. The silhouette clearly a hawk. He'd been circling these meadows before. Yeah, it's a little bit different. Let's try it again. Copy this one. Try it again with 2.0. You can see it's a little bit different now. The gray rabbit twitched its nose, sensing the scent of carrots nearby. Actually, this would be much nicer if I could show you with 2.5. Let me just see if it works now. No, it doesn't work now. Let's run it again. Yeah, it's a little bit different. The temperature matters. Let us try now. Temperature is something that you should tune and test out for your case to see that you get the answers as you want them to be. And I want to go into multimodal inputs now. Multimodal inputs. I will go up and copy. Yeah, I'll copy this one here. I want to try 2.5 Flash. And here to make, first I want to put in an image. I will create a folder called folder assets. And inside of this assets, I want to place in this image here. You can find it in my repository if you want to use the same one, which I will leave in the description, of course. But let us try this out now. For that image, I want to do like this. Remove this prompt here. Instead, I will have contents is made up of parts. And it has a list. And this list has two dictionaries. One that is text, and the text is, I will call, tell me about this dude in markdown format, comma, and then I will have another dictionary where I'll have inline data, colon, and here is another dictionary where I'll place in the picture, basically. The inline data, it's MIME type. MIME type is an image / PNG. This is an image. And then I will have data is basically open this path assets / auction.png, and I want to read binary .read. Let me see. I think I have some issues with this, some issues with parentheses here. This one and this one and this one was not closed. I've debugged and fixed it. Here is how it looks like. I've changed to Dash Pro because the Flash 2.5, it gave the server error again. I chose Gemini 2.5 Pro to test it out and it worked. I'm glad with that. Here I have these parts, and then I have text and inline data, basically. This is a dictionary as well. It's a dictionary with a key called parts where we have text, and we have another one, inline data, and inside inline data is a dictionary where you have to specify the format and to actually open the image, of course. The image is inside of assets / auction.png. And here I'll say, tell me about this dude, right in markdown format. Here is about this dude. Let's take a look in nicer formats. From pathlib import path, and then I will do path, export. So I will create this folder, exports, make dir, exist equals true. If it's exist, this doesn't do anything. Now I create this folder, and then I'll do with open, export / image description .nd, and then I will do as file, and then file.response.text, basically. I write this to markdown format, run. Perfect, and now I have this markdown. And then I will take a look into how it looks like. I think this was quite nice, and then overall impression. In summary, this dude is portrayed as an intelligent, as tech-savvy individual with a witty geek culture sense of humor. The combination of his intense focus, MacBook, and statistics team t-shirt strongly suggests he works or studies in a STEM field such as data science, statistics, computer science, engineering. Cool, quite nice. I like this multimodal inputs. I really like that the LLM actually found the joke and explained it as well. Maybe I didn't read it out, but you could have paused the video and read it out, but I can read it a little bit quickly here. He's wearing a like the punny graphic. The t-shirt features a clever pun based on statistics. Normal distribution. The top half displays a classic bell curve, a fundamentals concept in statistics and probability theory. And then we have paranormal distribution. The bottom half humorously reimagines the bell curve as a sad-looking ghost, creating a pun on the word paranormal. I really like those descriptions. It caught it quite well. And I hope that you've learned a lot in this video about Gemini and how to use it to work with text, how to use it to work with multimodal inputs and the temperature. We looked into the token. We took a look into the response object and how to work with that and get out different types of information, the metadata, where we could take a look into tokens. We took a look into thinking and tried out different models because of this server overload, unfortunately, on the 2.5 flash that happened when I was recording this video. But I hope that you've learned a lot, and make sure to commit and push your code to Git and GitHub, and see you in the next one. Thank you. Bye.